Welcome to the second video in Chapter 7. This one deals with ellipses. And I've written out some notes and some vocabulary that I'd like you to copy down, and then we will play with some of the equations and draw some of them. But first you need to know some of the parts. An ellipse is a set of all points in a plane where the sum of whose distances from two fixed points that are called foci is constant. Now it's important that you recognize that it's a sum. So we're adding in equations with ellipses, because when we get to hyperbolas it's going to be the difference. And you have 2 points now. Instead of with the parabola we had one focus, now you have foci. You've got 2 of them. And you have 2 fixed foci, and then you have the distance around them, the sum. You'll see the foci is a distance c from the center of our ellipse. Whereas, remember in the parabola, it was from the vertex to the vertex, it was a distance of p to the focus. Now, let's talk about some of the vocabulary. With ellipses, you have vertices that are on the same axis as the foci. They're the major axis. Excuse me. And those are called the vertices. Then you also have covertices that are on the perpendicular axis. And that would be the distance b. So the vertices are A from the center, going from the center out to A, or from the center up and down to the vertices. And remember, the foci would be on that same line, but it would only go out a distance of C. Covertices are distance of B. If the major axis is vertical, the covertices would be horizontal. Let's talk about the different axes. You have the major axis, which is a distance of 2a then in length, right? If you've got your center and you're going a and to the right and a to the left, then from vertex to vertex is a distance of 2a. It extends from vertex to vertex. The midpoint is the center, and it goes through the foci. So if I give you the length of the major axis, you would divide that by 2, and that would give you a. That would give you the distance a for your equation. Your center still goes through h and k. That's the same as with the parabola and the same as with all of our other equations that we've done. You have the minor axis that goes to the covertices. So that has a distance of 2b in length, right? Because it's going from the center up to b or down to b, or it could be a horizontally oriented ellipse. We'll see both here in a minute. The minor and the major axis are perpendicular to one another through the center of the ellipse. And sometimes you'll be given the foci, or you'll be given the vertices, or you have to calculate the others. So if you've noticed, we have a C distance, we have an A distance, and we have a B distance. Typically, you are given 2 out of the 3, and you have to find the other one. Okay? Now we're going to look at some equations. If you'll please pull this out from the notes that I gave you in class, and we're going to look at the different types of ellipses. Basically, you've got vertical ones and you have horizontal ones. And let's talk about the equations. Notice they're both sums, because we said they're both addition. That's a big clue. You notice they both have the h and the k. You'll notice h is always with x, k is always with y. They're squared, so we have a x squared term, we have a y squared term. And they have that gives us the center of the ellipse. Now if you'll notice, the a and the b are reversed. Now if I have the, let's play with the horizontal first. Horizontal is your x-axis. And if it is more horizontally oriented, longer going on the horizontal axis, the major axis, then that A is going to be under the X. That A is going to be the distance of the major axis. 2A is the major axis. So if you'll notice here, A is underneath the X, which is telling me the larger number is underneath the X, that it is going to be horizontal in nature. If the A is under the Y, then I know that's A squared, I know, but you take square root to get A. Then I know that it's more vertically oriented. And this distance would be A. From vertex to vertex would be 2A. Okay? So let's fill in some of this information. Let's first go to the picture and try to identify some of them. Let's do the horizontal first. So here, my horizontal, the center, and that's the same for both of them, is always going to be at H and K. Now if you'll notice, A is always the largest. Okay? A is the largest. A is largest. So here, if A is underneath the X, then that's telling me I have this distance here. This is my center, and it's telling me that this is a vertex, this is a vertex, and this distance right here is A. Okay? This distance right here is A. Now I think what I'm going to do is I'm going to write out the word center, because I don't want that C to be misinterpreted as the C distance to the focus. Let me see if I can zoom in here a little bit. There we go. That's a little bit easier to read. Now let's get some of these other distances. I want to put a distance of C on here. That means I'm going to come out here the same distance from the center, and I'm going to make that my focus. I have two of them, so they're foci. And the distance from the center to the foci, remember, is C. I've got A and C, I've left out B. B goes to the minor axis, my co-vertices. So that would be right here and right here. That distance would be B. The more you play with these, the more you will see they are pretty easy to deal with. And they're fun. I love conics. Let's label some of our axes here. This axis right here is our major axis. This one would be our minor axis. Okay, my center, if I had made the center, I did put the center right on the y-axis, but I didn't have to, right? I could have shifted it a little bit, and then I would have had a better h and k. Right now my h is 0, and my k is whatever that value is there on the y-axis. Let's go back and fill in some of these. The vertices are A from the center. It's going to be different over here when we do the vertical. The co-vertices are going to be B from the center. That's why I'm not putting in points. And the major axis is always 2A, and the minor axis is always 2B. The foci are C units from the center on the major axis. And it's important to note where the foci are, because that very often, as we saw with the parabolas, there can be different things that are at the foci point, focus point with a parabola, such as flashlights or on satellites. But here also, the foci are crucial when we are drawing this ellipse. got a very cool animation that I'll show you when you come to class about drawing the ellipse. And it involves those foci. Now, remember when I told you you have 3 values. You have an A, B, and a C, and typically you're given 2 and you need to find the third one. Well, here you go. This is what you're going to use to find the missing piece. You have A squared minus B squared is C squared. And if you can remember that the ellipse is the sum, so its equation is plus, then this equation to find the missing piece is minus, a subtraction. And likewise, when we deal with hyperbolas, this will be subtraction and this will be addition. So if you can just remember that if the equation is addition, then this equation to find the other one is subtraction. Let's quickly look at the vertical axis. It is very similar in that you still have all the same parts, right? These are the vertices. You have the center. You have a distance that goes up and down to the center. And that would, so your major axis here is 2A. Okay, this one is my major axis. This one is my minor axis. Let's put in some of the other points. B, this distance and that distance. There's your B on the minor axis to the co-vertices. You have the foci, and we'll put the foci up here. And the distance to the foci, remember, is a distance of C. So that's C, and that is your foci. And remember, this one is more vertical in nature, and the A is underneath the Y. Right here, because that's telling you it's a vertical ellipse. Right here. I'm going to circle the A, show you that that's what's different on both of those equations. And that's how you can tell very quickly if what orientation your ellipse has. Now let's talk about another vocabulary word, and that is the eccentricity. The eccentricity is the ratio of C to A. So it is the distance. Remember, C is to the foci, A is to the vertices. And if you do C over A, that indicates how much like an oval it is. If the C, if you notice, if the eccentricity is really close to 1, it's more like an oval. As the eccentricity diminishes, as the C becomes so much smaller than the A, then your ellipse becomes very much like a circle. Now if you'll notice here, your center and your foci are the same. C is right there in the center. Okay? So here you have A equals B equals the radius. You have a circle. That does not have a high eccentricity. It's 0 because it's a circle. It's very much not an oval. And what I'd like to do is to talk about also the equation of a circle, because a circle is an ellipse, but obviously an ellipse is not a circle. The whole thing, same thing with a square and rectangles, right? So here, we will do this when we come back in the next video. Thank you.